Hey everyone, day 23 today. We're almost at the end of this year. Just 3 more problems to go. Yeah, I mean, it's been a good year. It's been a little more grid heavy than I would have liked, but problems have been very interesting. No top 100 finishes, unfortunately, so my streak there might be ending soon. But it is what it is. Honestly, my results haven't been that different from most years. A lot of, between 500 and 1,000 results, which is roughly where I want to be. Okay, no grid today. A lot of connections. Connections are not directional, okay. There are 12 sets of interconnected. How many sets contain at least one computer with a name that starts with T? Sets of 3 computers where each computer is connected to the others. Okay, cool. So what we can do is we can have a set. Computer is just a string, so computers. Actually, I'm gonna make this a list, I think. No, we can make it a set, I guess. And we can just turn it into a list when we need to. Oh my goodness, I can't press the H key. And then we want a map of all the connections. Cool. So basically, for each line, right? So for string line and lines, we can just split it on the dash. So string first equals line dot split dash 0. Obviously second is very similar. And then what we can do is get the necessary sets. Right, so we have first, and then we have second, so I'm going to do f dot add second, s dot add first, and then we put them back. So connections dot put first f, connections dot put second s. This is very long-winded. Many languages would have been able to do that much faster, but that's how I like to do it. Okay, so now that we have everything, we can basically just have a list for indices, a new array list, and we can put in the set, which is computers, and we can check each group of 3. Of course, make sure to start your indices correctly, otherwise you either repeat things or end up with impossible setups, or just end up with slower setups. All are possible. So basically what we want to check is if, so let's get the first one, I guess. So if connections, actually, okay, we should just declare the 3. So string first equals for indices dot get I, string second equals for indices dot get j, and obviously third is okay. Cool. And now we just check if they're all strongly connected. If connections dot get first this is a very easy part 1. We'll see if it continues. I mean, obviously I'm not done yet, but this general principle has been done before quite a few times, so we'll see. So if it starts with T, if first dot starts with T, or second dot starts with T, third dot starts with T, answer plus equal 1. Zero. Lovely. That's not good. Let's do a quick check on for indices.size, see if it's empty. It is indeed empty. Ah, of course. We never add them in. So of course they're going to be empty. Nice. Alright, next part. The largest set of computers that are all connected to one another. The password is codecata. Oh, okay, I see. Interesting. Okay. So we want to find a fully connected group. I don't know of a clever way to do this. There almost certainly is one. But my general thought is pretty simple. Just maintain a list of lists, I guess. Yeah, let's do that. Yeah, okay. I'm going to make a private method basically, which is list to string. Obviously, I know there's toString already, but this is a very specific toString method because I want to go by their format. So sorted alphabetically, joined by commas. Okay. Luckily, this is a relatively easy format. We can just do pretty standard way to join it in. We do result plus equals comma, and result plus equals computer, and then we return, basically we return everything but the final character. I think that's how we do it. Okay, now basically we'll have a string that maintains the string form, and then we will have a connected groups. So basically we want to start by just adding everything in computers for string computer and computers. Connected groups dot add computer. Right. I probably could have done like list.of or something, but maybe I want to make it not mutable rather than immutable. Not sure. Doesn't really matter too much. Well, true. Basically, we want to get a new set new connected groups. Alright, I say set, but we're using a list here because we're actually going to use string forms to check. I guess string forms would probably be a set. Right, and then we want to do each array list, we want to see if there's an element that's connected to all of them. What did I call this? Connected group. Naming is really the hard part here, apparently. This is a remarkably easy part too, unless the complexity of my algorithm is much higher than I anticipate, which is very possible. So what we want to do is check everything in computers. I don't think anything has a connection to itself, which is good, because then we can do if connections.get s.contains all connected group. Right, then we want to do new connected group, array list, new connected group dot add all connected group. Then we want to add that new element, and do the string form thing. So I should add this here. String forms dot add cool. So basically, what is it we want to do here? If not string forms dot contains list to string of this group, then we add it. This is looking like enterprise Java already. Long name dot add long name. I do see one issue already. I will fix that. You might have also seen it. The issue is that this is not in order, so we do need to do a collections dot sort. Cool. And then at the end, if new connected groups, this should be new string forms, dot size is 0, that means we can't go bigger. Then we want to return string forms. Alright, there should only be one element, so we'll just do string forms iterator.next. Otherwise, we want to set everything to what it is. See if that works. Ooh, that's looking real ugly. Especially because I think everything is 2 letters. We're starting with a comma. Oops. Okay. I actually do need to rerun it because I don't know what the last letter is there. Nice. Alright, one of the fastest days, period, right? I mean, sub 15 minutes. Is that literally my fastest outside of like the first 5 days? Oh, no. Day 8. Oh, and day 19. Okay. The difficulty's gone way, way, way down. I mean, 14 minutes to solve the problem. Obviously, I mean, a relatively good time as well by me, but that's a wrap for today, I guess. See you tomorrow.